Welcome back to another Unreal Engine 4 tutorial. Now previously we could build basically forever, and it would allow us to build an infinite bridge. As you can see now, there is only a specific height limit that allows us to build. If we go above that limit, as you can see, it no longer allows us to build it. Now obviously you can set whatever limit you want. Mine isn't too big, but I think mine is big enough so that it looks a little bit realistic. And we are going to then create these extensions that will extend till the ground if it is within the allowed limits. And also it's going to have the same thing with the materials, completion, and all that stuff is going to work just fine. And yeah, let's get it started, and let's get rid of those floating bases. So as you can see, I added some small landscape just to have some elevation so that we can test out those infinite bridges, so that we no longer can build high up in the air floating buildings. So let's go ahead and start off by going to our build component first, because inside of our build cycle, probably before or after the check for overlap, we're going to add another function which is going to check for the distance from the ground for any specific object. So let's add ourselves a new function, and let's call this is build floating. There we go, is build floating. Now from here, very basic, we're going to do a line trace by channel again. There we go, we have a line trace, and for this one, let's grab our build transform. So essentially that is the location of the preview. Let's split that, and we can use its location. There we go. So that's going to be our starting position. Now the end position is we're going to grab the location, and we're going to do a minus vector. And in this one, let's do something like 500. And let's plug that into the end position. There we go. So that is all good and done. The next thing that we want to do is simply return. So let's go ahead and let's return. Add a return node, and it's going to tell us whether there is or there isn't something below us. So we can then just return this, and let's call this did hit. Let's call this did hit, because we cannot, because this is going to return as true if it didn't hit anything and is floating. Yeah, so it's better if we return true if we are allowed to build. That will make more sense with the naming conventions and everything. So with that being done, let's go to our build cycle. I'm going to move this part out, and I'm going to bring in our newly created function, is build floating. So let's reconnect the execution to over here. There we go. And from this one, there's two options. We could do an if, or what I'm going to do is I'm going to do a and. I'm going to bring this to the one below, like so. And actually, for better routing, let's do it like this. So first we're going to check for overlap, and then we are going to check is build floating, and then that's going to be the top one. There we go. And from this one, we need to return the not value instead. We need to flip it, because over here right now, if we have hit something, we are not allowing to build, but we need to make sure that both of these are true. So we need a not value so that it flips the true and false around. And then whenever we do something like this, it's going to be just fine as long as we swap these around. So now the is green needs to be at the true, and is green false needs to be at false. So let's flip these around. There we go. Or in this case, actually, we can even live without the branch. Technically, we should be able to just simply use this like so. There we go. So that's no longer necessary. There we go. So that's about right. So it's going to tell us whether we are allowed or not allowed to build. So let's give this a test. Let's hit play. Let's run up our hill, and let's try to I should have disabled that thing over there, so it doesn't show me those things unnecessarily. There we go. So let's run up the hill. Let's build something on our hill. There we go. We have 1, 2, 3, and the fourth one, as you can see, we are not allowed to build there. We can build over there, we can build over there, we can no longer build over there because the distance to the ground is too high, and it does not allow us to build there. Now, if you want to adjust the distance, make it higher or lower, then just go ahead inside of your isBuild floating for the -z, give it a bigger value. I'm going to be allowing only this much to be built above the ground. Basically have like a floating one, but we're going to fill up that empty space with some other models. So that's pretty much it for the build component. Now we got to do the adjustments inside of the actual foundation. That is the only object that's going to be allowed to be built like this. So we're going to go to our build foundation, and we're going to do some adjustments over here. So we have our on begin play event. We're going to do some stuff over here in a minute. First, we need to set up the locations from which we are going to do the tracing. So we need to add a couple of components to this guy. So what I'm going to do is simply use a arrow component, since those are basically invisible, so it's going to be just fine. So I'm going to call this one arrow 1. There we go. And we need to move these to every single one of the corners of this model. So we're going to have 4 of these. So one of those is going to be 200x and 200y. So then I'm going to duplicate this one and make this 200x minus 200y. Then I will duplicate both of these and do these minus 200x and minus 200x. There we go. So now I have 4 arrows all across in every single one of the corners. Now the rotation doesn't matter. The only thing that does matter is the location, because that's where we are going to shoot the line trace from. So just make sure that the z-axis is at 0 and that they are at the outer edges of the model. Good. So let's go ahead and let's set up ourselves a function, and let's call this trace. And from this we are going to do a line trace by channel. There we go. And this will need to have a input, and we will need to use this arrow component. So go ahead and add ourselves a new variable. Let's call this, I'm just going to call this component, but I'm going to look for the arrow component, or you can use a primitive component as well. It doesn't really matter that much. I'm just using an arrow, so I'm going to so that it's the same thing. Let's just use primitive component. It doesn't really matter because if you're using a different component, then you must use primitive component, because that one will support any type of component. So we have the component. Let's get its world location, and that is going to be the start position for the trace. Now the end position needs to be a vector minus vector, and we need to reduce some amount. So we did 500 over here. So over here, just in case, I'm going to do something a little bit more, so that in case if it's like 499 and I need another extra model, so that it would know that it needs another extra model. So I'm going to do like 800 over here. And that should do the trick for me. You can bump this up even higher, but it totally depends how big the model is. So mine, I already know, is going to be 200 units, so it's probably would be the best to use like 700 at max, but I'm going to stick with 800 for this one. There we go. So we have this. Now the next thing that we want to do is do an if, like so, and from here we want to break our hit result. And actually, we don't even need an if right here. We can then just simply return, and we're going to return 2 things. So we're going to return the distance, and we're going to return the hit. So I'm just going to call this did hit and the distance for the float value. There we go. So those are the 2 only values that we are going to return from this. There we go. So this is all ready to go. So now let's go ahead and let's set up ourselves another one, and let's say calculate distance from ground. Let's call it like that. So we're gonna need to run a couple of these. So we're gonna have trace 1 is gonna be ran for the arrow 1 like this, and what we're going to do next is we're going to do a if, see if it hits something. And then we are going to promote this distance to a local variable inside of our calculate distance to ground. So I'm going to call this local distance to ground, like so. And we're going to plug that into true. We're not going to use the false for this one. We're only going to use true, because what if some of the legs are a little bit below the ground? So maybe like you saw, so over here, as you can see, technically with this positioning, two of those arrows would be a little bit underground, so it's not going to detect anything. So we're going to do a true check to see, branch check to see if it's true, if we hit something, and then if we did, only then we're going to save it as a distance. The next thing that we want to do is go ahead and run our trace once more. So I'm going to do some back and forward like this. There we go. And we're going to do the same thing from the false as well. We're going to go back there as well, like so. Okay, so all good with that. Now let's run our next trace, which is then for the arrow 1, like so. Over here again, let's do an if to see if we actually hit something, and we're going to need to do another if, or we can run like two conditions at the same time. We got to check whether this distance right here is bigger. We want to see if it is bigger than the previous distance that we found, because we only need to store the biggest distance. We don't need to use all of them. We just need to find which is the biggest distance to the ground so that we know the maximum amount of these extensions that we will need to use. So I'm going to do a and, so did we hit, and is it bigger, like so. And then that one is our new condition, like so. And then again, from the true route, we can set our local distance to be this distance right here. And then just like before, let's go ahead and let's add a trace, and let's reconnect the execution to go back to over here, and let's reroute this once more. Here we go. So this is going to be quite a few reroutes. There we go, there we go, there we go. All good with that. Now what I'm going to do to save some time is I'm just going to copy all of this. I'm going to delete this and just paste that in. So we have another one, and we're going to need another one. So we're going to need 4 of those because we have 4 of those arrows. So reconnect the executions and drag the next arrow on top of this one. So arrow 2 goes to arrow 3, and this one goes to arrow 4. There we go. So that's all good. Now we are storing the longest distance at this point. The next thing that we should do is go ahead and grab our local distance to ground. And from here, we want to divide this. We want to do float divided by a float because it's going to return us the total distance. But we want to divide this so that we know how many instances we need to spawn. And to figure out with the other value of the division, we need to go ahead and look for our extension. So mine is this one right here, so the foundation extension. If I hover over this, the approximate size, you can see the z-axis is 204 units. Now I'm going to use only 400 so that they would overlap each other a little bit, and 200 is going to work perfectly for my situation. I would think so. If not, we're going to adjust it a little bit, but it should be just fine. So in that case, we're going to divide this by 200 since every single one of our objects is going to be 200. Here we go. The next thing that we are going to do is we are going to round this, or no, I think we need to truncate rather than round, so that it always would go upwards. 1.6 becomes 1. That's a good one. We might want to use round instead then, I would assume. Yeah, let's use round instead. There we go. So the next thing would be a regular for loop, like so. Plug in the execution, and instead of this round value to be the first index, it needs to be the last index, and the first index will need to be 1 so that it does create one extension, so to say. So from here, from the loops body, then we can add a static mesh component. So those are going to be our extensions essentially, and select this node and it will allow you to select the mesh. So I will need to use my foundation extensions, this one right here. And the next thing is to make the transform. So I'm going to split this to give me the location, rotation, and scale. All we need is the location because it's set for the relative, so it's going to be perfectly matching with our object. So for this one, we're going to use a multiply, and we're going to do a vector times integer, like so. Now the integer needs to be the index value right here, and the multiply value is the size in the z-axis for the model, so essentially this same value right here. So that's going to be 200, and in this case it needs to be a negative, so minus 200, so it would get spawned below our actual foundation. So now with this being done, we just need to run this. So let's go ahead and let's open up our event graph. And on begin play, after the loop has been completed, after we change the collision rules, over here, let's go ahead and let's calculate the distance from ground, and it's automatically going to add those extensions for us. So let's give it a test again. Let's run up the hill. There we go. Running, placing down 1, 2. It's already too high. Here we go. But as you can see, it did add those extensions. Now they are still a little bit floaty over here, so they don't seem to want to extend enough in this situation. So let me do some experimenting, and we're gonna see what is the best solution for that. So yeah, the only solution that I found that could be useful in this situation is just to always grab this round value and just add +1. Now, if you are not using landscapes, if you are using more like flat surfaces, then probably it's gonna do just fine for you. In my situation, I found out that I pretty much always will need another extra 1. So I'm just gonna do +1. So it's always gonna be at least 1 instance of this extension. So now, if we run back up, build it over there, over there, over there, as you can see, it extends pretty good, and we can no longer see anything floating in the air. So that's just fine. So I'm really happy with this. Now the next issue is that, well, we can not walk through this, and also it is not transparent, just like the top pieces over there for us. So let's go ahead and let's make sure that those are also transparent, has no collision and all that stuff. So the first thing, the transparency, let's go ahead, let's grab this static mesh component node, and we can change its properties just like we can change it over here. So we need to set up the material for it. So what we are going to do essentially is pretty much run the same code we did in the event graph, so we can have a little sneak peek over here to what we did. So let's go ahead, let's add ourselves a new variable for this build foundation, and let's call this foundation materials, or foundation materials, because we might have multiple materials. So let's make sure it's the same type. So we need the material interface, and we need an array. Well, in my situation, I don't need an array, but there might be multiple materials, so it's usually better to then just have it this way. Okay, so there we go. Now the next thing that we need is we need to store these static mesh components inside of the memory as well, because, well, they're not going to appear over here, so we cannot really like get these. So whenever we create one, what we want to do is let's go ahead, let's promote this to a variable, and let's call this extensions. So extensions. Now I'm going to disconnect this variable because I need an array of these. So I'm going to make this into an array. There we go. Recompile that, delete this, and let's go ahead, let's bring it in. So we have the extensions array. Let's get that and let's add to this variable. And we will need to then add the return value from the actual extension component, the static mesh component itself. So now it's going to store all of those inside of our memory. There we go. So that's good. So now that we have done this, let's go ahead to the loop's completion. So whenever we are done with the loop, let's go ahead, let's set our foundation materials so that we have them in our memory so we can restore those. And also let's go ahead, let's get our extensions that we just stored in the memory. And let's go ahead and let's get a copy to index number 0. So I'm just going to get one because all of them are the same. All of them are using the same exact materials. So we're just going to grab from the first one. And from here, we are going to get materials. Get materials, it's going to return us an array, and we can set that over here and then connect the execution to the loop's completion. So whenever we are done with creating these, then we are going to store their original materials in the memory. So now the next thing would be to go ahead and change the materials to the gray ones. So let's go ahead and let's grab all of our extensions. And let's do a loop for each so that we would go through all of those and change the materials for all of them. There we go. So we have done this. Now the next thing that we need to do is we need to change the materials. So let's go ahead and let's grab our foundation materials. Let's get those and let's do a loop for each for those ones as well. So we're going to have a small loop inside of a loop. There we go. That's always fun. And from here, what we are going to do is from the static mesh element, we are going to set the material. We're going to set its material. We're going to connect the execution to the second loop. So let me do some small rerouting so you see the wires a little bit better. So idea is like this. The element index is this index right here, and the material is our gray color material. Now the next thing is, whenever we are done with setting the materials for every single one of our extensions, we are also going to need to change their collision. So what I'm going to do is similar to what we did over here. So we can, just to save time, we can copy these two nodes. So set collision to response to all channels and response to a visibility channel. So over here we can paste those in, and we can connect those to the second loop's completion. So whenever we are done with setting the material for that one specific extension, then we want to change its collision as well, and then we want to do it for all of them. So again, let's go ahead and let's grab this right here. So that's our specific extension that we are working with right now going through the loop. So we're setting its collision to ignore, and then we are blocking its visibility trace channel so that we can interact with the object. There we go. So that's all good. Now we need to reset the materials back. So just in case, let's go ahead, let's test this. So now all the materials should be invisible. So if we do this, as you can see, all of them are nice and invisible. Oh, that wasn't too high, I guess. Let me just double check if we are not allowed. Yeah, that's good. Okay. So as you can see, we can now walk through all of these, and we can finish by interacting with the below parts as well. As you can see, we don't necessarily have to look up there because we just need to interact with the actor. Now the issue with this, as you can see, it does not finish the entire build for us. So let's go ahead and let's make sure that it does reset the collision rules and all that stuff as well. So what I'm going to do is actually copy this bit right here. So these nodes right here to the event graph itself, just to save some bit of time. So let's look for the location where we set our materials back. This is where we do that. We reset the material and we reset the collision. So after we have reset the collision for the base, let's go ahead and let's do the same thing for the rest of it as well. So we're going to go through all of the extensions. We're going to go ahead and loop through all of their materials, which we probably should. So then instead of this material, we then need to use this one right here. So from the arrays element, we got to use that material. And then for the collision response to all channels is block. So we're going to block that, remove the last node, and we should be good to go. So we go through all of those extensions, then we go through all of its materials and set those for that extension and reset the collision. Yeah, I think it's good. Let's go ahead, let's test this out. So again, let's build some up here. There we go. So we are back to normal. So our textures are back, our collisions are back, and everything is back. So yeah, that's gonna be it for today's video. Hope you found this useful. Hope you enjoyed it. If you did, make sure to subscribe, leave a like, all that good stuff, and see you in the next one.